Hey seniors, hey, we're going to be doing section 2, diffraction, and we're going to be talking about diffraction and diffraction grading. Please read pages 532 through page 545. Okay, now first let's define diffraction. Diffraction is a change in the direction of a wave when the wave encounters an obstacle, an opening, or an edge. Now the equation we did in the previous lesson, d sine of theta equals positive negative m times wavelength, where m equals 0, 1, 2, and 3. It can be used to calculate the wavelength of light if you know the grating spacing and the angle of deviation. Okay, so we're going to be using this formula to find, to use it in practice B. So if we look at practice B, it says monochromatic light from a helium neon laser with wavelength 632.8 nanometers shines at a right angle to the surface of a diffracting grating that contains 150,500 lines per meter. Find the angles at which one would observe the first order and second order maxima. Now here, in this, the information given is the following. We know the wavelength of the laser or of the monochromatic light, which would be 632.8 nanometers. So wavelength, 632.8 nanometers, which is equal to 6.328 times 10 to the negative 7 meters. Okay, so we need to find the angles for the first and second order maxima. So we need to find theta 1, theta 2. So we know that m equals 1 and 2. Now all we have to find first, now, and the other information that we have is that the diffraction grating contains 150,500 lines per meter. So d, the distance between each line, will be equal to the 1 over 150,500 meters. Okay, so that will be d. Now, that will be d. Now, since we're going to be using d sine of theta equals positive negative m times wavelength, okay, and we want to find theta, we're going to divide by d on both sides. So we get sine of theta equals positive negative m times wavelength over d. Now to find theta, we have to multiply both sides of the equation by the arc sine. So we get theta equals the arc sine of m times positive negative m times wavelength divided by d. Okay? So let's find first how much is 1 over 150,500. It will be equal to 6.645 times 10 to the negative 6 meters. This will be equal to d. Okay? So for theta 1 equals the arc sine of positive negative m times wavelength over d. For theta 1, we're going to be using m equals 1. Okay? So theta 1 equals the arc sine of 1 times the wavelength, which was equal to 632.8 meters, nanometers, sorry, divided by the distance, 1 over 150,500. Okay, so theta 1 equals the arc sine of 1 times nanometers to meters, that would be 6.328 times 10 to the negative 7 meters over 1 over 1000, we got 6.645 times 10 to the negative 6 meters. Okay. So we do, okay, 1 times all of this is the same, so that will be 6.328 times 10 to the negative 7 divided by parenthesis 6.645 exponential negative 6. So we got, that's what we get. Now shift sign of that equals 5.4465. So theta 1 equals 5.465 degrees. Okay? Now, the second angle, theta 2, we use the same formula, positive negative m times wavelength over d. The difference is that now we're going to be using m2, that's the second order maxima. All right, so now we get theta 2 equals 2 times 6.328 times 10 to the negative 7 meters divided by 6.645 times 10 to the negative 6 meters. Cancel meters with meters. So theta 2, I mean arc sine, sorry. So theta 2 equals 2 times 6.328 exponential negative 7 divided by 6.645 exponential negative 6. Okay. Now, to that, we have to find shift sign. And we get that the angle would be theta 2 will be 1.098 times 10 to the first, that will be 10.98 degrees. Okay, so that will be your solution. Those were going to be the angles at which one would observe the first order and the second order maxima. So whenever they give you what that diffraction grating contains, in this case they told us that it contained 150,500 lines per meter. To find the distance between each one of the lines, divide one by the divide one by 150 divided 150,500 lines per meter. So you're gonna do the inverse. You're gonna divide one by the number of lines per meter. So you're gonna be doing practice B, problems 1 through 5, page 538, and a chapter review, problems 19, 20, and 21, page 549. Okay, guys, I'll see you next week.